think we're back. And audio is behaving properly, so... Thanks, Aki! Sorry, stream. Yes, I'm no longer hearing crunchy audio, which is, I think, the nicest way I can put it. Yes, I will have to thank Jade for that. That was hard for me to listen to, even if it was fine for you. Anyway. So, let's get the VCD going. And then... chunk. I think this is going to... Oh. Huh, no. Why is that trying to do that? That should be using this. Oh, right. Sorry, Amy. I'm just gonna make sure that the file it's pulling, yeah, debug file is D electronics MXKeyboard build firmware, D electronics MXKeyboard build firmware. Yes, okay, so this will do the right thing. So we've just had ooh, interesting. That was a physical access failure. I have got a trace now though, but it's not on the right timescale. Let's try that one more time. Is this because I have such an amount of cable between things? Let's drop the JTAG frequency down then, and see what happens. Huh. I can't really go that much lower, surely. Ah, this is ridiculous. If I don't use the virtual machine and I use my host, oh, interesting. It didn't like that either. Well, no, shit isn't unplugged, that's the thing. This is going to be to do with reflections. what I am currently doing is I'm currently trying to figure out why my JTAG breakout board is not functioning properly. And it's probably because of the really long pieces of wire that I have attached on the ends, which it's probably not very much liking right now. That's probably the actual reason why it had a hissy fit. There we go. That wasn't so hard. Very much the wrong timescale though for my scope capture, which is unfortunate. I wonder what clock that used. So we know it can work. Yeah, okay, so that's now working. Go figure. Oh, and that's generating constant traffic, which this is dealing with, but it's going to make a very big value change dump. Oh, that's amazing. I'm getting some beautiful capture of data on my scope. Well, I've got some scope data now. Let's stop. Attach. Kill that. It's smaller than I thought it would be. Interesting. So let's put TMS at the top. TDI, TDO, SRST. Interesting. This is almost like, as I say, it's almost like it's got fully inverted logic or something, because this is not how it looks in scope planned. Like the TDI line should be high unless we see otherwise. Okay, yeah, this sequence here, for example, looks like there's a thing that happened here, then TDI does stuff, and then there's another thing that happened here on TMS. That's what this actually looks like, and I can see a pattern like that on my scope, but this is the change bits rather than the underlying data. So let's fix that. And let's see if I can get something correct this time. I'm just trying to fix something on my scope. There we go. Let's see what that did. TMS, TDI, TDO, SRST. Okay, so TDI is now high most of the time, like it should be. And yes, this is the exact kind of sequence I was seeing on my scope, where we'd get TMS pop high, then stuff happen with TDI, it would go low for a little bit, and then it would go back high again with another burst on TMS. So this is very promising. This looks like a legitimate dump for the board. Though it's got a lot of dead time in it, which is a little surprising. Okay, it's because the scrolling around in a VCD is really difficult. Okay. This should be the pattern I think it is. Yes. So I could see this part on my scope, I couldn't see the TDO wiggles. But this is exactly the kind of thing I was seeing. So we're good on that score. I'm very intrigued about this initial phase. Also, I really want to add a fake... I'm going to add a fake TCK, because if we actually need it, so we've got... JTAG state machine usually allows the change of values when TCK goes low. We sample when TCK goes high. So we'll create a TCK signal, which is initially low. Which is initially high. We'll do BCD writer change TCK signal cycle 0, and then on the other half of the cycle it goes high for sample. Yes, that should do the trick for that. So now if I do a run of the applet for the program side of things, and we just reprogram the board, we should have a reasonably nice, there's our clock, TMS, TDI, TDO, SRST, and yeah, that's awesome. So now we have a reference for what is happening in what cycle. Scrolling around in a VCD is a pain. Awesome. Do we try and make SIGROC ingest this file? Can SIGROC ingest this file? Or is it going to have a bad day? That's the question I now have. Because I now have a 1.9 megabyte VCD. Ouch. It's not, and yet, Jack Shaving 101, is it bare yet? Is it bare yet? Thanks. It's not that big, but also my memory usage was ballooning as soon as I opened any VCDs in PulseView. So if I run PulseView up real quick, and we tell it to not do that, I'm gonna watch my memory usage while we do this. Just a second while this loads. So we're gonna watch this going upwards, because yikes. Oh right, we need to tell it there are TCK, TMS, TDI, TDO, SRST. There's 5 channels. Go. Okay, that didn't suck. Interesting. And it didn't really change my memory usage. Curious. Now, the question I have... Add a protocol decoder. Okay, we can do this. We can ask it to be JTAG. Okay, so I happen to know that the instruction register should be 4 byte. Why is that paused here? Interesting. Oh, because we've told it TMS is low to start with, which it is not. That's why this is misbehaving in the way it is. Okay. So the decode should actually start all the way back here, but I need to tell it that TMS is low to start with. I think. Or not. No. Ah, I see. Hang on. So this puts out a 9-bit thing. We then have some idle time with TCK just TCK just doing its thing. And then we end up going into shift DR mode, shifting a whole shit ton of ones in. I.e. FF. Jeez. Until pause DR happens. And then we start doing actually useful things. So this is where I then need the data sheet, I think, because these should be PDI transactions, which means that we can actually see these are the program part of PDI, which is the documented part, which means we can actually go and see what the hell the instruction is that is being put into TDI, because it is actually documented in the datasheet. Poorly, but it is there. I need ocular. There it is. Always on top. Open programming, no, electronics, rather, docs, microcontrollers. I think it was in this data sheet where it actually does talk about how JTAG physical PDI controller works. Okay, so this last bit here should be parity. It's even parity, so there's one. So it's 1 to be able to make this an even number of ones. 1, 2, 3, 4, 5, 6 with a 1 means that that was an error response, I think. 1 EB. This is a very awful way to be viewing this. How do I tell it that... How do I tell it that its way of showing me what that is kind of garbage? I don't know. Anyway. That's F5. This is the JTAG physical for the PDI side of things. What did it send to the... What did it send to the controller? It sent... LDCS, apparently, in that one. This is an LDS. That's another LDCS. It goes back and forth doing that a couple of times. This should then be a LD. Except that 0 should be, that 1 should be a 0. Interesting, so this... This is weird. Doesn't quite make sense in my head. No, it's almost like I've got the clock wrong. Almost like everything is shifted because the value changes are happening in the middle of the... Yeah, you can see here the valid time started on the rising edge. And it ignored the value change there. Oh, right, this is it going back to idle state. No, that's correct. This is 0, 0, 1, 1, 0, 0, 0, 0, 0, which is exactly what we get here. And that is actually even paritied correctly. Although that... Oh! Yes! No, you are right, Obliterous. That is an undocumented command. Specifically because of that one bit. Unless that is the data for the previous... It's complicated. Well, yeah, so this is the exact reason why we're doing this in the first place, is that this thing is a giant ball of that. They only tell you about how the program part of PDI works. They do not tell you about how the debug part works. So it is entirely probable for us to see stuff here that just isn't in the manual. That's the whole point. What I was hoping to do is I was hoping to kind of match like the NVMe key, for example. Sorry, the NVM key, so that we can see it. Yes, it literally is what Glasgow was made for. I'm looking to see if we can get to a point where we can recognize the basic programming sequence, maybe the bytes of the binary that are being sent, so we have a kind of sense for the structure of this data in pulse view. So if we zoom out a bit, and let's go down a bit, let's go to, there's a 32-bit thing, interesting. This is very annoying that we can't get a direct read of TDI because it's deciding to format it with the bits on the right-hand margin rather than the left-hand margin. What I'd like it to be doing here is formatting this as 6, 7, 1, hex 671, because that would actually be much more useful here. How do we... That's not very much control over how it's doing the disassembly of this. We aren't dealing with JTAG, and we don't really care about STM32 JTAG. Ooh, there is an MXKeyboard thing. Well, yeah, that's reasonable that it reports an error because those, the PDI data signal is the claps of the TDI and TDO. Oh, this is nasty. Oh, that's the other really funny thing about TDI here is that technically, the least significant bit is the first bit transmitted. So that there is actually hex 1, then hex 0, then hex 60. Because Amel hates people. That's the only thing I can think, is that Amel hates people. Sent using the key instruction. So we want to see an instruction which has 3 bits, a high 3 bits set. And everything else zeroed. I wonder if this massive string of ones here is to do with forcing the PDI controller into a known state. That could be an interesting one. It's very hard to tell though. So, going to the top here, JTAG physical. We have TMS, TCK, TDI, TDO. Great. There's a special break instruction that it can put out. Yes, it is a very long reset, I think. To guarantee that we are in a idle state in PDI. Because the PDI controller is separate from the JTAG controller. There's a... good question. How many bits is that? Other than writing to memory outside of pulse view. It doesn't say. It's a lot though. Oops. How about I want to get rid of that one? How do I get rid of... That'll do. If we work on the assumption that that is the low bit first, which is as documented in the frame format, that makes that I have a funny feeling this is in order already, so yes, this would make this an LDCS with CS address of 0. And then it's loading 0 into that register, I'm guessing. PDI instruction and addressing registers or internal registers. Okay, so immediately after an instruction there will be some number of bytes. How big is the LDCS register? That's an interesting question. Yeah. Glad to hear it. Okay, so I'm gonna say this is an LDCS, then we write a 0 into the first thing. LDCS again, same location, write a 0. Then this is that LDS instruction for, and then that's loading 6, 7 into whatever the thing is at address. Or, oh, hang on, this is a size A, size B. Size A of 1, size B of 2. So, a word and 3 bytes. All you people managing to get vaccinated, I wish I could. Just saying. So we should see... Oh, okay. Let's open a calculator. We've got 6, 7. So 6, 7, 1, 0. It varies from person to person. And then we have so this looks to be the address, and then the value to write. I'm sorry, Obliterus. What is at that address in this microcontroller? Where's the memory layout gone? That one. Indeed, okay, indeed. I'm trying to work out... I don't want the memories, I want, peripheral modules. Peripheral module addresses. Okay, so this is an undocumented address that it's writing to. That's great. Oh, jeez. The other place that could be trying to write to is EEPROM, which you shouldn't be writing to. Yeah, this very much feels like it could be very worth filtering out the valid transactions here. I don't know which of those is the right kind of thing to save this as. Because I really only want to save this. Yeah, I fully expect it is, because, well, this was just me trying to dump the programming of the board, and we've already hit some weirdness and undocumented and just okay. That's a package, isn't it, that I need to install? I don't have SIGROG CLI installed. I have the rest of it installed, which is now fixed. This was program, wasn't it? Yes, this was program. Okie dokie. Okay, so that actually reduced our BCD from 1.9 megabytes to 54K. But we now have a proper thing that we can dissect, probably. Yeah, see, it's... we can probably discard a lot of this file, which is great. The only problem is going to be... Welcome back. God, that kind of made a butchery of it. Oh, I kind of keep trying to put the C in, but... Capital I for input format. Oops. So, supported input formats, it's all lowercase BCD. And yeah, that should have done the trick. I can certainly punt the trace over to you. Electronic, sorry, no, programming, 1 bit squared, Glasgow, program VCD. There you go. I almost want to say that I want to chain a UART decoder over the top. Nice. But I don't really see a decoder here that would do the trick. This is the closest. It's not a UART then. That would be closer to... What? Baud rate would this be? This would be... the... Because we're on the nanosecond scale here. Holy crap, that actually kind of worked. It's not great, but it kind of sort of worked. We don't have stop bits. And we don't have start bits, but yeah. So this is a way of potentially doing this. It's not good though, because like we are cutting data off. it's trying to treat that as being a start bit. Maybe it could be treated as a SPI then? So we'd have PCK, PDI, TDO. There is no chip select. Okay, that's got the right phasing and such. LSB first, word size 8. Kind of. It's a shame that SIGROC here isn't allowing me to basically say, hey, use the output of the JTAG decoder as your input, because that would be ideal in this case. Like, if I could take these bits and stuff them into a UART decoder, I could tell the UART decoder, hey, yeah, this has got even parity, just decode it. Because that is essentially what this darn thing talks. Is there a... Because it's essentially a USART is what I want to decode. Yeah, really. I mean, I could tell it, hey, it's PS2, but that wouldn't help in this case. That is actually quite cool, though. I don't care about SWD. Yeah. Vigant is another whole fun protocol. Again, not what we're after here. Yeah, this doesn't have the ability to say, here's a universal synchronous receiver transmitter, go. Or chain from like a JTAG decoder into a UART decoder. Which would be ideal here because, as I say, I could then say, you know, here's your receive and transmit. It's even parity, LSB first, and we would have a reasonable decode. Indeed. There is a SD card SD mode here, but I don't know if it works. Ooh. Thank you, dear. the JTAG dash a JTAG equals bit strings. Ah, I see. Oh hey! Oh, that's awesome. Especially as that right there is an instruction being loaded. And that matches what I was expecting, which is 4-bit instructions. Excellent. Thank you. Interestingly though, that doesn't have... Oof. That doesn't have all of the decode. It stops way too quickly. That's... the first little bit, but not the rest. It's still... that was even shorter. Have we found a way in which SIGROC is broken? Because yeah, this is clearly too short. Given this monstrously large quantity of shit. Which should be in that file. Let's find out. That's the same as if I'd said bit strings. That's a very good question. It looks like you have to specify both, but that's still short. It's very weird that. Well, this feels like one of those things where we're gonna have to mess around and see what we can get to happen with SIGROC, or if we have to write something, I guess. But I'm inclined to kind of tie things up here because it's 1:30 in the morning for me. And yeah, we've got a decent amount done at least. So, like, we've got the JTAG adapter stuff working. We wrote a Glasgow applet today. I mean, that's not shabby, right? We wrote a Glasgow applet and it works. That's kind of cool. It's been an interesting stream, that's for sure. I'm glad that the adjustment of the row resistors worked out, because that proved a point, which is very nice. Next stream, which will be next Saturday, I think I want to finally get myself back to a Spare Flash programmer. I have been working on it off because reasons, and that will be to try and debug the read side of things with the Spy Flash that wasn't working. And that, yeah, really. And in the meantime, we'll work on trying to figure out the decode for this data dump stuff that we've now got, to get it down to, distilled down to a usable sort of, here's the PDI transactions that were happening, here's the underlying JTAG instruction register flippy that was happening, and all of that stuff. See what we can do. I will do another try with the VCD dumper we've now got with my virtual machine at some point. And yeah, thank you all for watching. It's been interesting. And I'll see you next stream for some Spy Flash Programmer, I think. Take care all. Bye for now.